Thought of that instead of just putting a camera in there with a sensor.
Oh, with this?
Yeah, they could have just had the camera in there with the sensor and then had the microphone on it.
Yeah, yeah, you could do that, but this it uses your mobile phone to use the Wi-Fi network to send your videos away straight away, so it's not recording it on your phone, could have, gotcha.
It just seems a bit weird because you've got this, you've got the clip which follows you around, but is also the microphone. Whereas, if you move but you want it to stay on the screen and you go to draw something, it's hard.
Yeah. All right, so up to project 3 building. So we'll have a look at this, have a look at the procedure document first up to get that introduction for that happening. Okay. So having a look at that. Say no. Rightio. That's all the same information as for your planning approval. So, develop models to meet requirements of required client floor layout, electrical requirement, fire safety requirements, landscape design, conservation requirements, underfloor heating, life safety plan. Previously, I'd gotten students to do a reflected ceiling plan as well to meet that electrical requirement, but because we're doing exit signage and emergency lighting, etc., within our fire plan, we're meeting that electrical requirement as well. So I'm comfortable with that. So that's all fairly standard: site analysis, site plan, floor plan, area, elevations, etc. These sections in green are typically the bits you've got to pay most attention to in the building approval. So sections: all aspects to be supported on detail sheets from reports provided and/or reference to the NCC and Australian standards, including relevant specific clauses for our longitudinal section, stairs and lift, showing roof structure. So there are two options really you could go with for your roof structure for this building. One of them is that you could go with it being a metal decking roof with a pitch to it, and then that slopes toward a box gutter, and that box gutter then is linked up with rain head and your downpipes. So that's one option you can go with. Or you could also what's very, very common commercial detail is to have a flat concrete roof and then have a waterproof membrane on top of that roof, and then have some sort of flat roof drainage system. So you've got your little drainage outlets interspersed on your roof, and then and your drainage happens in that fashion. I'm happy with either way. If you want to be working through using a flat concrete roof and exploring having an EPDM membrane on top with a roof drainage system, that's fine. And I put a flat roof drain detail in the Learn page as well for you to have a look at. Both systems are fairly applicable. It's good to understand either. So whichever one you want to go with. I think Army, with planning approval, you'd like to try doing a green roof on yours, so you're limited to doing that concrete roof with your plants and your drainage medium, etc. And your drainage points with the EPDM membrane underneath. So whichever way you want to go with, I'm fine with. And what I'm expecting is that you guys will be in at least every Wednesday from now on, because there's a little bit more to work with. I wanted to get you started on these details now, so that you can bring them in and we can discuss and we can sit down and work through some of those bits and pieces as well individually, because I think that's going to be a little bit more involved than what we've done with Project 1 and Project 2. So that's the roof structure. Then some details around wall structure. So that's going to be based around your cladding choices primarily. So show your wall structure. As with Project 1 and Project 2, this is going to be best completed by use of detail lines. So use some of your automatic sections as a reference, but primarily it's going to be detail lines. And then floor structure. So that's going to be, I expect that your floors are going to be long span concrete floors in the building. And the rest is fairly straightforward. So stairs, including stair numbering to meet compliance, and lift dimensions, etc. That shouldn't be new to you. So you've got that roof structure and that wall structure and floor structure, and the details that you have to do with that is detail through parapet and detail through balcony. With what your roof choice is, that's going to that's going to influence how your parapet detail comes together. Whether you've got your flat concrete roof and your EPDM membrane carried up onto that parapet, that's I guess essentially that's going to be the less time consuming detail to draw of those options, whereas if you were to go to your box gutter, well, it's going to be a little bit more detailed with that. And then also balcony, several ways you can go about that. One is to have if you were to have some sort of truss type system for your flooring, then you can carry out that balcony detail as a continuation of that trussed, some form of framing type system for your balcony. But the method I suggest for this building, what I'd expect to see on site is that it's actually a concrete floor formed up, and that concrete floor is carried out past the facade of the building and creating the balcony. So this is the balcony that's at the rear of the building, by the way. So we're not punching through our curtain wall glazing for a balcony. We're taking that out the back. I think that's going to be also it's going to be a simpler detail to draw as well, because it's about carrying that concrete floor out and providing a set down in that and a slope on that to meet your drainage. So this is what we're going to have a look at today, and have a look at the resources and the thinking around that, just to get you started on that. What we'll be looking at later on is underfloor heating plan. So for the ground floor only, you're to do an underfloor heating plan. There, within product information, I put in a guide, an underfloor heating guide produced by Rehau. So Rehau, they're a pipe manufacturer. They do underfloor heating. That's hydronic heating. So that's in the under product specification section. However, also once you work your way through, once you've done task 3, the quiz for task 3, you get given additional information. There's more underfloor heating information in there as well. So you won't start on that underfloor stuff straight away. I think focus on the details for now. But if you're wanting to move on, then complete that quiz for part 3, and you get more underfloor heating information with that. Then following on from that, you've got your life safety plan to complete. So that's to show path of egress should a life-threatening emergency occur. And as I mentioned briefly earlier on, your intended audience for that is also the private certifier. So you want to be showing your exit travel distances. Then you have the fire safety plan as well. Both of these can be incorporated if your details aren't getting if there's not too much information going onto the one plan. So I'm fine with those two being incorporated, and there are benefits in incorporating those as well. One of them is with the fire safety plan, you've got to show your exit signage. Now your exit signage has to be placed in a way that is going to be visible to people in the point of emergency. And one of the things you think about with your placement of that exit signage is where people are going to go, where they're going to be, how that exit is going to happen in the case of an emergency. So if you've worked through your life safety plan, you go, okay, well these are my exits here. Well, then that helps clarify that picture for you about your exit signage as well. So that's one of the benefits of pulling them together. But so the essentials for this are your paths of travel and your distances to those exits. Your essentials within the fire safety plan are location of hydrants, location of hose reels, locations of exit signage, locations of fire extinguishers, and locations of smoke detectors and emergency lighting. The rest is fairly straightforward and similar to what you've done in other projects. So what we'll have a look at today are those details and the information for those details. Do any of you know? Do any of you have an idea of, or apart from you, Army, do either of you two have an idea about what sort of roof you'll be looking at and what sort of balcony you think you'll be looking at this point in time? Definitely concrete for you? Yeah.
The roof would probably be the...
Yeah. Yeah. It really depends on what form you wish to explore. Yeah, I tend to think the box cutter detail is probably something you're more inclined to use, and so explore that one if you.
What's it like to install though compared to the other one? Because the box cutter detail is harder to install and easier to screw up. So what's the other one like?
Yeah, so the other one is it's essentially it's much easier to draw, much easier to install. I'd say, look, as long as the installation of the waterproofing membrane has been done correctly and you follow the manufacturer's instructions with that waterproofing membrane, I think it's less likely to fail as well than your box cutters as well. So box cutters are kind of renowned for their failure, and there are many issues that come about with box cutters. So I think in terms of failure, that's the most likely one to have issues with. But your truss type construction with a sheet roof and a box cutter is going to be a cheaper form of construction than forming up your concrete floor. But the benefit in you guys doing that detail and working through that detail here in this class is you're more likely to be doing that, working with that particular detail. I reckon there's a greater chance that you're going to be working with that detail in industry, because it's not just a detail which is used for commercial construction. You use very similar detail and processes for residential construction. There's a whole lot of residential construction that have either box gutters or parapet gutters, and also for industrial. So that's for your warehouses. It's on like this building here. It's all box gutters. It's not parapets, but it's sawtooth roofs. The interaction between your box gutter and your sawtooth roof is pretty much the same as your interaction between your box gutter and your parapet as well. So, I've done one drawing professionally with membranes. I can't think of how many drawings I've done with box gutters, but it's a lot. So, So you're far more likely to do that. So, but it'll take you a bit more time. So either way, I'm happy with. So what we'll have a look at now is some of the resources for you. So once you complete task, task task 5, duty of care, and what is it? No, sorry. So task 3, reports, technical. You'll get that information, and so there's some information in there, as I said. It's relating to all sorts of aspects, but we also have this section down here for details, and that's what we'll be having a look at now. So this is, that's the detail I popped in just before for any of you that want to do a flat roof. That's to give you an idea of the drain, particularly of the flat roof drains that you'd be using in that flat-formed concrete roof. Not all of these aspects you have to include. So for that, you may want to have some rigid foam insulation, etc., in your roof, or you may be going straight onto your formed concrete as well. That's not the important point. The important point is to understand that we've got these small drains hooked up with that drainage pipework, and that we have typically it's going to be, in Australia, it's going to be an EPDM membrane that folds down under those drains, and so we get sealing under that, but we have a.
Would we have any concrete or anything over the top of that?
No, so no concrete goes over the top of it. So that's the top roof surface there. So for those at home, can you see? Oh, you can sort of see it relatively well. So we've got our roofing, that black roofing membrane. There we go. There's the leader to it there. The black roofing membrane. That is our roof surface.
That's your roof surface.
That's the roof surface.
Because in terms of I'd say rooftop gardens and stuff like that. If anywhere where you have kids or whatever playing around, you don't want you want something sort of.
Oh yeah.
Is there a finish or something that goes over the top that can be put over the top so that layer stays protected?
Well, the use of the EPDM membranes, that's typically not for. Well, I don't know of it being used in a trafficable situation. It's not for.
Sort of using that roof area for something, or like if no one's going on it, then it wouldn't.
Yeah. So it's trafficable in the sense of people going up there to service, air conditioners or whatever services you have on your roof, but it's not. I most definitely wouldn't use that for a public area.
So what did you put on there in that case?
Don't know. Haven't dealt with that. If it's a green roof, if it's going to be trafficable for a green roof, well then what we have is we'll have a depth of this aggregate here to provide drainage, and then we have a drainage medium on top of that. Then we have a growing medium on top of that, and then we have plants, and of course that's trafficable.
But say that it was essentially raised beds. So you have.
So we're talking about roof garden.
You have a seating area and a normal area, and then you have these raised beds on either side. Would there be something that you put over there?
Yeah. Well, I wouldn't use this membrane system for that. I would treat it more like you treat a balcony, where you have much more fall toward your drainage points. So you've got to have a 1 in 100 fall to your drainage points. Then I would have there are membranes which are designed for external use under tiles. So similar to the paint-on membranes in your bathrooms. So you'd have one of those membranes, and then you'd have a flooring surface above that, ceramic tile or some form of tile over that membrane. The same way that you do within a bathroom. So
would that be would that system be applicable if you were to put like a deck over the top of it? Because essentially the deck will still let the water through, and that would still be the water system.
Yeah.
But of course, attaching the deck to the
Yes, that'd be the point at which I'd expect things to be leaking, and also the supporting of a deck on top of a membrane, even if you're not piercing through the membrane, I imagine there'd be issues in terms of any movement and wear that happens as a result of that as well. Yeah, possibly. Look, never gone through that process of designing a membrane to go underneath a decking scenario, but you might want to have a much stronger membrane, like a fiberglass membrane or something like that you go on top of for that. But no, that goes beyond what I've worked with, so understand. The only thing I've really had first-hand experience with was tennis court on top of a membrane, which is very similar to your green roof scenario. Although I guess that's another thing. That's a possibility. You could have a membrane, and then you could have a geotextile fabric layer, and then fake grass on top of that. I mean, that would enable sufficient protection of your membrane, sufficient drainage for any water that makes it through your fake grass. So that, exactly how you deal with a deck on top, it'd be problematic, I think. Yeah, inviting trouble. But look, I guess essentially, maybe I steer you away from getting too experimental with this roof in that regard. But the options I was wanting to talk about there is if you've got a concrete roof and your EPDM membrane as a non-trafficable roof like this with drainage points, or you look at the box gutter detail, and also what I'm not expecting you to be sizing up is your number of drainage points, etc. for this roof. Either that goes beyond. I have an idea of how I'd go about it, but that goes beyond what I would personally want to be specifying myself.
Who would be doing that?
Who would be doing that? I don't actually know. So in the office where I worked, one of the engineers would have done that. Yeah. But if we're to employ and that was a structural engineering office, so, but it's not. I don't think it's typically the role of a structural engineer to determine that. Look, it might be a hydraulic engineer for that. Yeah. So that's the detail for your flat roof drain. Okay, we've got to look at these individually. So there's a detail in here for your balcony. Now that detail is for a framed up balcony. So James, do you reckon you'd be doing concrete floor extended out as well, or framing, or
concrete floor as well?
Yeah. All right. So we'll speak about it more in that context then. So what we'll be doing, and what similarities will there be? So whether it's framed or whether it's a continuation of that concrete slab, you're going to have to provide a set down. This set down is so balcony finish floor level minimum 50 millimeters and maximum below internal finished floor level, and they've set it at 96. So you're going to have minimum of 50 millimeter set down from your floor to your balcony, and if you're going to be tiling your balcony, you'll have to give it that extra 10 millimeters for that. Then you're going to, and another thing that's going to be similar between both details is the fall. So you're going to have a fall of 1 in 100. Because we're dealing with very small balconies and they're at the rear of the building, I'm happy with water runoff to be going off the edge of balconies for your details. If we were going to detail this this up in terms of we're not allowing our water to exit off the end of our balcony, then we would have a hob here, similar like same like you do in a shower, or you'd have some sort of detail for actually retaining water on the balcony, and then you'd have the slope to a drain as well. Be that it may be a strip drain right at the end, so you have a strip drain right at the end, and you're picking it up there, or it might be drainage points along like a floor waste gully, similar in a bathroom like that. But if you're going to have a drain or have the fall to each of those drainage points, you've got to. It's very similar scenario like in your bathroom. You've got your screed going on top of your set down floor, and then your waterproof membrane either underneath or on top, and then that folds into your drain. Yeah, but I'm happy. Yeah, look, if you want to be working through balconies that retain the water and then run that to drainage pipes, I'm happy to work through those details with you as they come through. Otherwise, I'm also happy with that water going straight off the end of the balcony. Other aspects that are going to be the same, so obviously you're going to have a balustrade, so your balustrade, minimum 1 metre in height, same as your and your baluster spacing's the same as normal 125 millimetre sphere not to pass through. We are going to have one of the things that's going to be in a concrete floor balcony detail that's not in this one is your reinforcing as well. So you're going to be carrying reinforcing through. Once we get past this edge of the building here, we're turning it from a span into a cantilever. Our reinforcing details are going to be different in that regard. Do I have... No, there's not a pen there. So we're going to want to include our reinforcing at the top over this point at which our concrete exits our building. So that's going to be the majority of that reinforcing. With a slab spanning from point of support to point of support, the majority of your reinforcing is at the base or toward the base of your slab, because that's where your concentration of tensile forces is greater. You guys, that's making sense to everyone with that? Yeah, cool. No, and we sort of cover that materials and methods as well, but just making sure that's all understood. But as soon as you get to a point at which you start cantilevering, well, then you have your reinforcing up the top here. We're not specifying any reinforcing. This is indicative only. But you will have your standard sort of notes to say reinforcing as per engineer's details. But understand that that's where your reinforcing is going to sit primarily for once we exit that building edge. Other aspects to be included on that, so your concrete detail is going to be quite a bit simpler than your framed up detail. Look, I think that's probably about as much explanation as you need for your balcony detail when you're going with concrete. For anybody going with framing it up, you could basically use this detail as your guide. That's there's not except for your dimensions. Although if you were going to be framing it up and going with this detail relies on joists which are running perpendicular to the edge of your parallel to the edge of your building, which means you'll need to have supports carried out at set distances running perpendicular to your building as well. So that detail would then also have I-beams in the background that your joists are locating on, and they cantilever out from the building to carry those loads. So that's that one. For your box gutter detail, we're going to be dealing with, however we do it, we're going to be dealing with a parapet. We're going to neaten up the building and to help hide surfaces and things like that. You want to carry parapets past the roof line of the building. Certainly if you're doing a green roof, it's designed to be a trafficable area, well then you'd want your parapets or balustrading or something at least a metre high, higher than your green roof. So the important details with that are, well, there's one is the size of the box gutter. So we've got to think about what box gutter size we have to accommodate. Have any of you done box gutter sizing already? Yep. Yeah. And what's
That's easy to use the other.
yeah.
Now there's a website we got told about. Go on there.
Yeah.
The information.
Exactly. So yeah. So in the Learn page, I'll go into. I'll digress just a little bit. So in product, scroll down please. Right, in product information, we've got information on box gutters, and that's a really good information sheet on on designing and specifying and installing box gutters. But then also there's the link here to the box gutter calculator. Really good resource for basically any. This is not only box gutters but you can size up eaves gutters there, and you size up downpipes, things like that. So, do all of you know what the rainfall intensity is for Adelaide? Anybody know what the rainfall intensity for Adelaide is?
Can't remember that.
But yeah. For Adelaide it's 124 millimetres. The way I remember that is because for paving adjacent buildings, you have to as soon as you get over a rainfall intensity of 125 millimetres, you've got to increase all your slope around your building with all your paving. And Adelaide sits 1 millimetre below that increased requirement. So we're at 124. If we were 1 millimetre more with our rainfall intensity, then our paving around our houses would have to be different. So we dodged a bullet there. So with that box gutter, how we go? So we go more calculators. We go to box gutter to rain head, simplified. And so in going through that, look, if you remember your 124, you can pop that straight into there. Otherwise, you can choose your location as well. Well, actually, 174. Oops, sorry. Oh dear. Okay, I might have to revisit that. Dear me. Okay. Yeah. Maybe it's maybe that cutoff is 175, but maybe remembering that incorrectly. Anyhow, so don't rely on me off the top of my head. Go with your Adelaide City. So then you punch your numbers into there. Let's go catchment. So our roof there's around that 400 square metres, roof slope of 5, and box gutter. So if we have a look at that, our box gutter information, our minimum fall for that box gutter is 1 in 200. So we'll go with that. We want to go with that minimum. And our trial box gutter width, I suggest putting in 300 for that. So we're going to have several downpipes happening in there. Okay, so let's make it 200. We've got 200 square metres going into our box gutter for that. So with having 2 downpipes off of our roof, we've got so minimum gutter depth with slope 140 millimetres and a 300 wide box gutter.
When you get to 300, the trial box gutter width from?
So that's your minimum size for your parapet gutter. So if we were to have a look in, so we go back to the Learn page and have a look in the box gutter information. So industry guides, industry guides to good practice recommend minimum base widths of 500 millimetres for valleys and 300 millimetres for parapet and boundary wall gutters. So we're trying to get the smallest one in there we can. You can increase that if you wish. Just quickly in having a look at this. An additional freeboard over the maximum water level is recommended to allow for splashing and waves up to 75 millimetres. So freeboard, that is additional height of your box gutter as well. So that means like this is your expected water level, and that's your additional height, your freeboard. So that's what that refers to. I guess it's a boating term or something like that for how much something is above the water level. So there's this information page on your box gutters, and so longitudinal slope must be between 1 in 200 and 1 in 40. So we went for our minimum slope in that. It sets out the method of design of a box gutter is as follows: determine the catchment area, drainage to each downpipe, determine the design, 5-minute duration, etc. But we can get that from the box gutter calculator. So there's that information page, and your box gutter calculator, and that will give you your box gutter. So we have those two figures. Then also you want to size up your rainwater head from that as well, which is also included in that. Where are we? So we've determined our box gutter calculator. We've determined our box gutter size, and then we've got rainwater head, enter the trial downpipe size nearest to the suggested diameter above. So we've got 125. Well, I'll suggest knock that back to 100. See how we go with that. And that's not an unreasonable size rainwater head on that. So we can keep those downpipes fairly small, and then we've got our rainwater head size. So we're working through that. So we've determined our box gutter size, determined our rainwater head size, and now also determined our downpipe size. Other aspects we're going to have to include. We're going to have to specify some sheeting and slope of your sheeting. The rest of this can be indicative. Including the ceiling system underneath. you'll want to include some indicative insulation in there as well. But the thing that you should be aware of and should show is your parapet flashing here as well. The thing that you have to remember with any of your flashings is that flashings higher up lap over top of flashings that are lower down. So this flashing will have to lap into your gutter, and your gutter will carry up closest to the parapet, and then you'll have a flashing lap into that gutter from...
Not that you can really see it as well, but that flashing needs to flick away.
Yeah, to let drips. Yeah.
Because otherwise it will absorb the water, like the water will go and suck all the way back up into the rest of the timber.
Yeah, through capillary action.
Yeah.
Is it? Yeah. And so, yeah, but with your... Yeah, okay, yes, I guess with your same principle applies with your parapet flashing there as well. And then you have to have a parapet capping over top of that as well to lap over top of that flashing going into your gutter. And then whichever walling system you've chosen for your... Catch you later. And whatever walling system you've chosen for your external of your building and how you're going to include that on there. Do either of you... I can't think off the top of my head either which walling system either of you have gone with for yours specified. No, it's been a while. Yeah, that's okay. So probably the best port of call is to go with manufacturer specifications for those details. Find what specifications are there for that, and then that's your box cutter detail. So if you're going with I guess we've covered it fairly well for if you're going with your flat concrete roof. You're going to have what I don't have here ready is a detail for the flash or the EPDM membrane going up your formed parapet, and then a flashing coming over the top of that.
Well, that would essentially be the same as the coming out and over.
Yes, it comes out and over, but those details, you're going to grab one of those from your membrane supplier. So there'll be an EPDM membrane supplier, and they're a flexible flashing which fixes over top of that EPDM membrane, and then so you'll get that in your product information for those membranes. But I think the better detail. I've seen details for a flexible flashing to go over top of the EPDM membrane, and then that's fixed to the back of the parapet and a sealant at the back of that. But I think a better detail is to actually carry a flashing all the way down the side of your parapet and lap over that flexible flashing over top of your EPDM membrane. I have not seen a detail that has a steel, a folded sheet metal membrane going on directly on top of the EPDM membrane, and I think the reason I haven't seen a detail like that is because you'd get wearing between the two, or there's that possibility for puncture of your membrane, your softer membrane happening as a result of that. Then another detail here, it's a little bit clearer, showing the interaction between your parapet and suspended ceiling. and then a Rondo suspended ceiling detail there as well. The rest, I think, are primarily residential details that aren't going to be of interest to you for that one. Yeah. So so if you're going with that whichever roof you want, whichever roof you go with. So there's pretty much all the information you need there for doing your parapet and box gutter. If you're going with the EPDM membrane, search a supplier, get the supplier's details on that flashing for that parapet detail. But basically, it's just a matter of the membrane going on top of your flat concrete roof, and then that folds up and carries up your parapet. So quite a bit simpler than your I think that'd be about it to get you going with that. Any questions at all? No.
With the concrete balconies, if we have the water just running off, would we have like a little lip on the bottom side of the concrete? So that
yes. Yep. Yeah.
Would that be angled, or would that just be straight down and then angled on the inside? So it would come down like that and then be straight.
You can do it with a drip groove. So you have a groove in the underside of your concrete there. So set just inside your concrete balcony as that comes out. Oh, so that's without the ability to draw it. So we've got our flat underside, and then we have a little concave groove on the underside, like a 10, So you'd form that with a 10 mil rod or something, or with your form, you'd have a bead placed in there just to make sure there's a little concave bit on the underside of that concrete soffit, so that.
So you're going in.
Yeah.
Sorry.
Yeah.
I was thinking convex because you'd have.
No, concave. So water doesn't want to travel back up. So it gets to that point. It goes, oh, no, I'm not going to go in there. Okay, I'll jump off. Yeah. So that'd be the simple way to do it. Yeah. Cool. All right. Well, I'll stop that.